Yeah.
I'm able to hear.
Sure.
Yeah.
We have two conditions. So even this condition should be added based on some other condition. You want to add like if employee belong to Italy equals employee dot contr country if it is equal to Italy, only then ITALY, only then you want to add this department condition, else we should not add it. So then it will be very complex to write, right? So there comes the criteria. Using criteria, right, we can add, keep on adding criteria like CRI criteria CQ equal to new criteria, something like that, and where we will write the object name, create criteria. RA, and to this criteria, right, we will add the condition. We will add the query dot add. You can add select start from, not select start from, right? Just you can add like CQ dot query or CQ dot the class name. What is the class name? Like here employee, right? EMPLOYE employee dot class, and it is going to do all the things. And here we can add condition if EMPLOYE employee dot COUNT equal to ITAL5, and then add another one criteria, add another one condition like here comes up something called restrictions and projections. Restriction dot like, here we can give IT, else we don't want to do anything and we can just add this condition alone. Else if 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 employee belongs to some other country like UK, right? If employee belongs to some other country like UK, and here you will add another one criteria. So restriction dot GT for greater than 10K. So like this we can add, we can have more conditions, more criteria based on two conditions. We can add, so we can generate very big query with this approach. We will see. Okay, we will see two examples. So yeah. Okay. One of the methods in criteria API which allows you to build a criteria query object programmatically, where you can apply filtration rules and logical conditions. So we can also write few more logical conditions and filtrations by making use of this API, criteria API. Criteria interface provides methods to apply criteria such as retrieving all the records of tables, salary is greater than 500, and lot of conditions we can add. So advantage is SQL provides methods to add criteria so that it is easy for Java programmers to add criteria. So Java programmer is able to add 20 criteria and query. Let's go and see one example. So here we have one entity object, CB user, and here in Hibernate config we have configured that, and these are the property files, and in app.java we have an actual all the queries. So let me put all these in the comment and let us execute one by one slowly.
I have a doubt actually. In Hibernate config, is it mandatory to give all that mapping classes?
This one config. These are the properties, and this mapping classes is mandatory.
It's mandatory. Okay, because today
Yeah,
I was trying that one-to-one, one-to-many, so I didn't give this and it was failing. But once I
yeah.
given this,
Mhm. This
yeah.
mandatory.
Okay, okay, okay. Yeah.
So here we have so this Hibernate it will write, it is going to read this configuration file. It's going to read this configuration file and it is going to give it to the session factory. Session factory, from session factory we can open on session to talk to this database with this URL and database name and username, password, everything, and to this class, to this object table. So which is running in my localhost, database name and table name. That's what we are specifying here. So it will give the session. So inside the session we can have a transaction, we can do a transaction, and so we can see the database. So here you can see the criteria, which is from Hibernate API, Hibernate org dot criteria, which is not there in JPA. So history of Hibernate is like it came from JPA. So Hibernate has implemented all the methods of JPA specification, which is given by a microsystem. And there we have, here we have what is that? Here we have Hibernate session factory. There we have entity manager, session factory. There we have entity manager factory, which will create entity managers. Using this entity managers, we will do first we will write queries, and I'll show one example on that, so we can see the father of the Hibernate, like where it came from. Okay, and so yeah, here is the criteria session dot create criteria, which is from Hibernate. Even the session, right? It is from Hibernate, and it is going to load all the tables. We didn't write. We are not going to write any query select star from dbuser.class. Nothing. Just create criteria dbuser.class. That's it. No select statement. So we will just run this. Yes. Let me manually insert one row created by say created by user, right? DB user created by this DBA SYS DBA and created date 7 date 10 12 2014 and here username admin apply. Okay, there was an exception. So we will execute this query manually and give the current date CURRENT DAT. First test function. Let's execute this and comment it COMMIT comment. Okay, got committed. Let us retrieve the rows. I could see 25, 2015 1 and today's date 7. Okay, so now let us try to with it. Gives one row. It's just a criteria. So now I'll show one application which uses persistent XML JPA and yeah JPA, and it uses EJB, and front end it uses JSF, Java Server Faces application. So this is fully an EJB workspace. Same DB user. Okay, here we have criteria query, which is from persistent Java Xcut persistent package, JPA package, which is from EJ, which comes along with J2WE, which comes along with the J2WE. Java. So let us try to deploy it. Morning it was not working. Just a minute. Let me deploy it. So we have configured that in the Wildfly server. If you see Wildfly 8.0, here we created one data source. Let us try to deploy it. So in this EAR, right, how this works is like there are web layer. First we will run it and then I will show. So server is starting, and it's a JBoss server, JBoss version 8.0. Initializing Mojoro persistence and I started. Okay. So this is a web application. So whatever you see here, it is a standalone application, and this is a web application. Let me click on it. It's still output is 0. Okay. So this application, right? It is just like here you can see it, entity manager. There we have session factory, and this is an EJB. So it has web module and service layer and persistent layer. CRSISP and persistent LAYR layer. And web module we use JSF. This web module is the test web page. This page, index.js, whatever we see here. DB user. So which passes a request to this servlet. This one. And this servlet has an EJB. So this EJB will take us to test EJB project, which is our service component, business service component. This is EJB, and EJB will have methods to talk to JPA project. This DB user, it is again mapped to this one. It is again mapped to this JPA test persistent project, which is a JPA project. Okay, like here it is mapped to JPA, and finally each and everything is going to be a different module. All this module we are going to combine and form an EAR application. So this EAR application we are deploying it in the Wildfly server, JBoss server. So test EAR, this one. Test EAR, if we expand it, you could see the modules EJB, test EJB, and test web war file. So test war file we have added for this 4 projects. 1, 2, 3, 4. All these 4 projects. which has JSF and servlet and JPA and EJB, all of them. I'm searching for one named query. We will try that. We'll see how it goes. Actually, it should return a result 1, but it is giving 0. Even morning it was giving 0. Let's try with named query using JPA query interface. We will see. So we'll be seeing this one also. Let's try once. Create query result set. Maximum is going to be. I think this maximum is going to be named queue named query. Create named query name, and set parameters you want, and the result set. Okay, so we'll try to use this in our part. We should use DB user and import the query from Java processing, and it should return this list. Return results. Before returning, let us print results dot size. It should be 1, and parameter will remote, and name the query name. This is the name, right? db dot find db user dot find all. Let us read that also. Here db user dot find all. That is the named query name, and in our persistent dot XML we also have that model class db user. Okay, now let us stop the server and try to delete the EAR and again start it. So I'll also show you the server, and this configuration will take. We can directly configure in our JBoss server. Local host, local So here, see, right, we have this. We are using MySql database, and in runtime we have deployed EAR file. JP here, this one. So we have one data source configured, and you can also test the connection. Inside success. So same data source name we have used in our persistent.xml. Yes, both the names will be same. So let us deploy it once. See, ER, right click, run on server on while fly. So ER will contain the persistent and all the things that we loaded. And these are the J and A names. So using the J and A names, we will access the beans. We will access the service method. run this and just so. And it's not getting all the executing all the results. It is executing, but every time we are getting the result set result size as 0. You know why? Okay, let's come back to this example. So here in Hibernate, right? So let's come back. Let's do the JPA, and here in Hibernate we are going to use session.getCriteria. It's going to load all the database and all the rows. We didn't write any select start from queries, no SQL or no HQL or no NAPE query. Just we are going to create a criteria and we are going to make use of this criteria API with the Hibernate. So it will retrieve all the rows, right? Next example, we command this block and it has opened this one. Okay, this one. It is order by. So here you see, right, this one criteria, and again we are adding an order. Add order by descending. Also I can split it. I'll write the criteria. Criteria order dot same message. So we can add the conditions like this. Keep on. We can add many conditions like this. We can add a lot of projections, restrictions, and all those things. I'll have just one. So it is going to order based on created date. Let us try to insert few more rows. Okay. Two. So if we have two users created by SDBA and RAM. Okay, first we will order by created by table name, created by table. So in this DB user we have created by with this property. Let me order by start, and we will execute this one. So what we are going to do, like we have created a criteria, we have added a condition, and we will get the list. This will return the result set, and the result is going to be DB user, from which we are going to iterate through this DB user, and we are going to print some statements. Let's run this. So on. Okay. So you can see, right. So this select this as user created by. So this is Hibernate query. It executed this query on these two still here. List criteria order dot list. This method is going to execute this. This method is going to execute this query, and it will return the result set, bind it to the DB user, and from that we are going to get this one. So we didn't write any query, right? Select start from table name or object name or entity name, where condition equal to group by order by DESC created by. We didn't do anything. So just we wrote one criteria and added criterion to this criteria, and that's it. These two lines has given us. So okay, created by, right? So okay, let us get print the created by names. Only then we will be able to know what is the order it is displaying. Right click in the server application. So it is a default descending order, so it comes like this: DBA first and ROM. Let me make it AESC, same property. So now you can see, right, ROM comes first and DBA comes next. It's getting reversed. Okay. So next example, again I will comment this section till here and open this and put it this one. This one. Yeah. And we have something like restrictions and projections in criteria to add few more conditions. First, we will add this one. So there is a restriction for equal to, less than, greater than, and less than equal to, greater than equal to, like, between, is null, is not null, and few more things. Okay, so we can this restrictions dot give dot. We can see a lot of things. We can check equal to, size is equal to, size is greater than, SQL restrictions, like property, disjunctions, conjunctions, and or clause, or even logical operations are also possible, or and if ID equals, all equals, not. Okay, and SQL restrictions. Okay, also you can explore on that. So we will just execute this query. So what we are trying to get is like restrictions should, where username is equal to Superman. It will give 0 result because we don't have any username Superman. Username, I'll make it as this one, admin1, this is admin2. Apply, and we will try to get the admin2 username like admin2, and this set max result and set first result. This for pagination. So let's say you have 1000 rows. Okay, you want to start from 500 rows or 450, row number 450. From 450 you want to get 550 rows. So for that we can set first result as 450, get me the 50 rows maximum result. Get me the 50 rows. This should come first and this should come next. So start from 450 and get me to 50. This will help in pagination. So now we added one restriction. We'll just execute that. We'll see how many rows it is going to come. And username, DB username, okay, username, right? Okay. So it's giving 1, admin 2. So that's the username we gave, right? Username equal to. So let us give 1. So it's giving 1, admin 1. So similarly, we can add few restrictions for user ID. You can see, right? User ID 99, 100, greater than 99, greater than equal to, like, between, all those things. So you could create a table called DB user, and you can have user ID with 99, or let us keep 2 because we have only 2 entries, right? 1, 2. So let me remove this one and comment this one. So let us on this. So it's going to give the second user. Object. Let's get to the first. Okay, we are given greater than, right? That is the problem. Greater than 2. We don't have rows greater than 2. So we will say greater than equal to 2. Now you see, right? You got 1. So let's say greater GT 1. greater than 1, then it will give 1 row, right? Then or greater than equal to 1, then it will be 2 rows. Okay, 2 rows. So like this, we can also have like equal to and all those conditions. This first and max, we can use that for batch paginations and all those things. So next is the native SQL in Hibernate. So suppose business says like, and we don't want to write. Okay, just a minute. We'll comment this. Okay. Now the business says like we are not going to change the database, and still application ends. We will use only Oracle. We are not going to change the Oracle database. We might change a version from Oracle 9G, Oracle 9i to 10G, 10G to 11G, 11G to 12, 13 like that. But we won't migrate to some other database. In that case, we can directly use the table name. That is native to the database. We are going to write a query which is native to the database, which will be like an ordinary SQL query. So even for ordinary query, right, the Hibernate provides the support. If you want to write a native SQL query using the query using the Hibernate, even then it provides support. We can make use of this create SQL query from the session object to write an SQL query, which is a native SQL query. So select star from DB user, which will return your result set, which will give you a list, and we can also we can also change it to a DB user. We can also wrap it to DB user object, and we can print this. So just we'll print the size, so in this two. So native query is like database specific query where you can write joins, inner joins, outer joins, left joins, right out, and you can use, then you can have multiple tables, DB user, D, comma, employee, A, comma, and all those things is possible. Whatever we do in SQL, right, then we can do it here. So next, it's about named native queries. So here in this DB user, right, this on this admin username, we have admin2. We give admin2, and just on this. It's going to print size 1. So where we configured this get all DBs is here. In this object, in this DB user object, we have created a named query annotation, named queries for this is going this name is going to return this query where username, you are going to give a username, it is going to fetch that username. Similarly, you can have multiple named queries. Here you could say like comma, you can separate this comma. So here you can say like you want to get rather than getting all employees, get DB users greater than get DB users salary, say lay or y salary greater than 10K. This is the query. This is a query named query name. Here we can write the condition where username is there, right? Similarly, we can have, what is that? We can have, okay, let's say user ID greater than salary, user ID greater than, or stop to user ID greater than 1, greater 1. So here you can write the condition user ID greater than equal to 1. This one query. Similarly, you can have multiple queries. Let us try to execute this query, and we can use that name here. Session dot get named query. Using the names, we are going to run the query, and we don't want to set any string. Let me remove it, because for this we are not going to pass any. So here we are not going to pass any input, right? Here we are passing username, but for this we are not going to pass any input. Come back. Let me comment this, and so it has written 2, which means admin 1 and admin 2. Let's go back and make it as greater than 1. So it should return only 1. Okay, it returned only 1. So this is fine. So these are different techniques. We can use using Hibernate. Using Hibernate API, we can create a criteria. We can create a named query. We can create a native query, and we can also write SQL object querying based on the entity object. So all these 4 different ways of retrieval Hibernate supports. Okay, so let's go to the slide now and we'll see. So criteria interface provides many methods to specify the criteria. Object of criteria can be obtained by calling create criteria method of the session interface. Okay, this is a syntax. We want to use criteria equal to create criteria. This is a class name dbuser.class, and we have methods like add. We can add criteria. We can add orders. We can get set first result, set max results, specify the number of records to be retrieved. This will help in pagination. Result returns list containing the object. This is the actual one where the select query will be executed. And set projection specifies the projection, like we can set some projection also as a group by having all those things we can do in this projection. So restriction classes have these functions greater than, less than, equal to, not equal to, and or, and a few more things which are right. So even those things are supported in the restrictions class of the selection of the criteria. And order class, we can do ascending order, descending order using the order class. And these are the different examples for restrictions. You can do null, not null, is empty, not empty, when these conditions are also possible. Let's say you want to retrieve only null rows. You want to know how many rows are null. You want to know how many rows are not null. Then you can add this restriction. Get me the rows, get me the number of rows from the employee table. Add where restriction, you can say like restriction dot is not null, which will return you list of employees whose salary is not null or whose salary is null. If you put this one, it will give like salary is null, all those empty. So pagination, set first result, you will set like 1. It should start with first one, and it can go till 10. For next 10, again it will let's say the table has 100 rows, so it will start with 1 and max it is going to 10. It's going to result, it's going to give you 10. Again this result, right? Again this result you want to get like it's going to be in multi-dimensional array. So from zeroth index will contain first 10. First 0 1 index number 1 will contain 11 to 20. Index number 2 will contain 21 to 30. Index number 4 will contain 31 to 40. Like that, it goes on. So sorting, you can also do sorting like add order descending. This will do sorting. You can make use of this order class to sort your results either in ascending or descending order. So this is a descending order sorting method. Saw that, and projections and aggregations. So using the projections, right, we can write the aggregation methods. Aggregation methods like get row count, get distinct row count, maximum, minimum, average, sum, and all of this. Criteria provides Hibernate criterion dot protection class, which can be used to get average, maximum, minimum, property values. So so just order class, projection class, restrictions, criteria class. So only 4 classes, only 4 API classes of the criteria in the Hibernate for SQL. And then native SQL, DB specific, MySQL specific, you can write the query. You can also use native SQL to express the DB database specific queries if you want to utilize the database specific queries like connect keyword in Oracle. Hibernate 3 allows you to specify handwritten SQL, including stored procedures, create, update, delete, and you can also do all those operations using the SQL. Session interface and SQL query interface. So these are the interface which will support. Okay, you can also make use of this link. Just a minute, I'll open this link. We have in this SQL query we have scalar queries, we have entity queries, which we will add entities here. Here we won't add any. We will add scalars, Hibernate scalars, and we also have something called the named queries. We use name and native queries. So these are different types of native queries which are specific to database. We can write named SQL queries, native SQL queries, entity queries, and scalar queries. So scalar queries, just an example here. We have said like this is an employee table. This is an employee table. Directly we are giving an employee table, and this query SQL query, right? It's going to execute the value, and here we are going to add some scalar values, alias to entity map, similar to entity map, and it is going to return. It is going to transform the result, and it is going to give the value. So for more information, just you can refer to this document doc. Mostly this is less used actually. Native queries it will be used very less. They will go with criteria or SQL when it comes to Hibernate. Mostly SQL or they use criteria worst case. If it requires very complex joins and all right, then we'll go with SQL. So entity queries directly we will add entity. So it is native query only. If you see here, right, it is a native query. Employee table name, not an object name. But once the query is getting executed, we are adding an entity as an employee class. So what happens? It executes a query. It gives a result set. So there is a binding which happens. So whatever the result it got, right, a raw data which will be binded to this employee object. So above query were all about returning a scalar values, basically returning a raw values from the result set, and this raw values are binded to this employee class. And named SQL queries. Even if you see it is an SQL query here, still here it is SQL query, but here we have added also the property. This property belongs to an object. Ultimately, right? This property belongs to an object. So this is an SQL query, but so it is a named SQL query. Along with that, it also has the entity attached to it. So it is going to return an employee with this ID. Let's say 10, 20 employee ID is going to return that employee object result set, and finally we are going to bind the values to this employee object, okay, and we are going to return. We are going to get the result. So here we have an example for native SQL queries. Like we have directly we want to configure that in the Hibernate config.xml file, table name, and all these properties. Okay, so native SQL just session.save, which we have configured here, right? So here we have, if you see here, right, generator class is native. It's going to the type, the ID type is going to make use of the native type. So just this is all about retrieval and query language in the Hibernate. So we saw first SQL, which is the basic fundamental one. Hibernate query language, we query based on object, and SQL, we make use of the criterion API to add more criteria at one time on based on some conditions. Also, we can add some criteria. In criterion API, we have order, we have projections, we have restrictions, and order, projections, restrictions, right? So this we have. We can have aggregate functions. We can add some greater than less than conditions, logical conditions, right? And then we saw native SQL. There are 4 different types of native SQL: scalar and named SQL and named join with SQL. So all 4 types mixed, right? We saw those 4 types. So named native SQL, named queries, native queries, named queries, SQL, and SQL. 4 types, 4 languages for retrieving data from database in Hibernate API using Hibernate session APIs.